Okay, I want to work a couple of these application problems. I worked a couple on Canvas along with explicitly giving you the definition of an angle of depression and an angle of elevation, so you need to go back to your Canvas pages as usual. Alright, so this first example I'm going to work is talking about a wire attached to the top of a communications tower, blah blah blah. So like everything in this course, you need to draw a picture, regardless if it's just drawing a right triangle or if I give you a word problem. You know that so far all we're talking about is right triangles, so somehow a right triangle is going to come out of this information. Alright, so if I'm going to draw a picture of this, what I'm looking at is a communication tower. And then we've got a guy wire that's attached to it going down to the ground. So we have the ground down here. And the information that I'm given is it says that the wire is 600 feet and that the wire also makes an angle of 65 degrees with the ground. So that's this angle right here, and that's 65 degrees. And they're wanting to know how tall this tower is. So that's my tower, that's X. That tower's going straight up and down. Alright, the wire's what is going at an angle. So let's look and see what the relationship is between what we're given and what the angle is that I was given. So I've got 65 degrees is my theta. I'm looking for X, which is across from it, so that's the opposite. I'm given the wire, which is across from the right angle. Remember, we're going to have a right triangle here. Alright, so that's my hypotenuse. So we're talking about the opposite and the hypotenuse. So if we're talking about the opposite and the hypotenuse, we're talking about sine. So we know that the sine of 65 degrees is going to equal the opposite over the hypotenuse, right? Cross multiply like we've been doing. So I've got 600 times the sine of 65 degrees equals X. And so X, just plug that in your calculator, 600 times the sine of 65 degrees, and you're going to find that the height of that tower is approximately 544 feet. Alright, so like I said, go back. There's a couple more in Canvas if you want to watch another application problem. And those are pretty straightforward in 6.2. This one was one of the last ones that I'm assigned for homework, and I'm going to work it out. It's a little bit trickier just because there's more algebra involved, but you just need to recognize the basic trig applications that you need to use here. So the problem is about a hiker, and then we're given an angle of depression and an angle of elevation. That picture was actually already drawn in the book, so I went ahead and drew it in my on this as well. So it's already been drawn for you. So we've got a flagpole, we've got a person looking up, looking down, blah blah blah. Alright, so we are looking for the distance from the hiker to that flagpole. So we're looking for X here. And like I said, that was already labeled. Alright, so we don't have enough information to just set up a trig ratio and be done with it. What we do know is that the height of the flagpole is 60. So this entire thing right here is 60. But I have to break it up because I have a right triangle formed by the angle of elevation, and I've got a right triangle formed by the angle of depression. So I'm dealing with right triangles here. So I'm just going to say, well, this part of that first right triangle, I'm going to call that A, and the second part I'm going to call B. Alright, so we're going to use that to help us. Now that we have at least a label going on, we can at least set up some equations and try to figure out what's happening. So the relationship between A and X and that top triangle, so I'm looking at the triangle with the 18 degree angle. So 18 and A and X. Well, A is across, so that is my opposite. And then X is adjacent, it's next to it. So I know that the tangent, because I'm talking about opposite and adjacent, the tangent of 18 is going to equal A over X. Or I could say that A equals X times the tangent of 18, and that's just by cross multiplying. All right, I've got two unknowns there, so there's not really anything else I can do with that. All right, if I look at the 14, the angle with the 14-degree angle, I'm doing the same thing. I'm looking across to B, that's my opposite, X is still my adjacent. So I know that the tangent of 14 is B over X, or likewise B is going to equal X times the tangent of 14. All right, so like I said, we still got two unknowns, so where am I going with this? Well, the only thing that I do know is that A plus B is 60. So if I added these two things together, I've got A plus B equals 60. That was given, that's the height of the flagpole. So if I add these two expressions together, A plus B, I know that A plus B equals 60. So 60 has to equal X times the tangent of 18 plus X times the tangent of 14. All right, now I'm getting a little bit closer because I'm looking for X. X is my unknown, and this is where all the algebra comes in, because if I look at this expression right here, I'm trying to isolate X. To isolate X, I could just factor it out or take it out of both of those terms. So I've got X times the tangent of 18 plus the tangent of 14, which means when I isolate X, I'm just dividing both sides by all that. Same thing over here. So X is going to be 60 divided by the tangent of 18 plus the tangent of 14. And that you can plug in your calculator. When you plug that in your calculator, you just divide 60 divided by tangent of 18 plus the tangent of 14. Make sure you, when you divide, you put 60 divided by parentheses tangent of 18 plus the tangent of 14 degrees. And the distance between the hiker and that pole is about 104.5